Hello, and welcome to our February Spotlight webinar with Syxsense. Today, we have our industry expert, Graham Brooks, here to give us an inside look into how to craft a flexible and dynamic endpoint compliance management framework for zero trust and continuous compliance using Syxsense Enterprise. If you have any questions, please add them to the chat, and Graham will reach out after to answer those. And with that, Graham Brooks.
Thank you, Joe. All righty, so I'm actually really excited for today's session because I always really enjoy getting to use the tools themselves and not just talk about theory. Theory is great and it's really important, but at the end of the day, I'm more on the deployment side. I like to spend my time actually creating solutions, and that's what we're going to do on this session. Before we actually look at the product, though, I do want to take a couple minutes to reintroduce the theory so that you understand the background. If you want a deeper dive, take a look at our last webcast we did on intelligent endpoints from January, where I went into a significant amount of depth on how intelligent endpoints can be crafted and essentially the theory behind it. Okay, so what is an intelligent endpoint? This is my working definition. Other practitioners might have their own thoughts. It's a brand new space, people. So just appreciate that we're figuring it out as we go, and we're trying to come up with something useful. My definition is that an intelligent endpoint is capable of safely performing IT management tasks without direct administrator intervention or supervision. So this is kind of different than the more traditional process of asset and IT device management, where you're pushing out policies on maybe a weekly or monthly basis. And it's instead moving towards a model of continuous compliance, AKA we look for a baseline, we look for requirements. And if we find deviation from those baseline requirements, we then enforce that baseline back into compliance on an ongoing basis, rather than that staccato once a week, once a month approach. Okay, so that's kind of the definition of an intelligent endpoint. There are a couple key components that we're going to be using as we build our intelligent endpoint framework today. The first key component is going to be the concept of safe automation. You don't want to do too much too fast, because if you approach it too heavy-handedly, you can break things. And we're not trying to create new problems for your IT team. We're trying to resolve existing problems. So that's our first statement, is as we build this automation, we need to do it in a way that's safe. And if you want a more thorough explanation of that definition of safe, I recommend you look at last month's webcast, and we're going to spend some time architecting that today. The next key takeaway is the idea of independent automation, aka no IT admin is clicking a button that tells the device to perform an action. Rather, that action is being performed dynamically given an input. All right, and then the last key component is timely automation. We need this work to happen essentially in real time. So as events are occurring on devices, we want to be resolving any compliance issues that might be arising from those events. So those are our key components. Last, before I jump into the product, I want to kind of show you what the actual framework looks like, from the old school monthly compliance policy style to the continuous compliance style of management. The monthly old school compliance standard has two teams, a security team and an operations team. Security team builds a list of vulnerabilities to be managed. Operations then works through those vulnerabilities, fixing them, and then restoring the devices to a good state, sending a report back over to security, showing them what work got done. That's the traditional approach. And you can see that there are, in fact, 7 steps in that process. On the other side, we have our continuous compliance model, which has been reduced down to 5 steps. And it's no longer a cycle. It's now a cycle with an exit point. So you've got this control plane process where we are evaluating and informing the team of issues that are happening that then generates information for analysis, which is then analyzed and determined whether to be enacted on or not by both the security and operations team working as a team rather than siloed, which then turns into a compliance policy that gets driven back to the console plane, which at all stages of work is constantly monitoring endpoints. And those endpoints are in turn returning information to the control plane, telling it what needs to be done. So that's kind of the framework that we're working with today. I'm going to show you how we built that together. All right, so moving into the console for the demonstration, I want to just give a brief background on what Syxsense does, how it works, and how it can help in that continuous compliance IT automation space. We are a cloud-hosted endpoint management product with an agent-based installation method. What this means is, regardless of whether you have devices on-prem or remote or in the cloud or wherever else, we're going to be able to manage them dynamically and directly without the need for direct internet access or VPN access or whatever other restrictions you might have. As long as they can communicate back to Syxsense, either directly over the internet or without internet access through a proxy, we're going to be able to manage them as long as they have our agent installed. Once that agent's installed, we can start collecting real-time telemetry as well as scheduled vulnerability and compliance scans against your devices. And today we're going to build out a process of management together so you can see what a dynamic endpoint management scheme might look like. First up, you can see on the sidebar here, I've got some really basic data. I can show you what the health is of a device, and then I also have pins here showing where my devices are located. And today we're going to spend all of our time focused on my lab environment in Salt Lake City, Utah, which if I go over to devices here on the sidebar and select the United States, go into Salt Lake City, Utah, and then go into my lab, you can see that I have a bunch of Windows and Linux devices in here. So this is the environment that we're going to be focusing on. Next, we're going to start building out some basic compliance policies that we're going to run on these devices on an ongoing basis. To do that, we go over to Cortex. This is the automation engine for our platform. This is really where all of the magic happens. I'm going to enter my intelligent endpoint postures list, and we're going to start building a couple management policies. The first one I'm going to build is pretty simple: antivirus. Is it running? Is it not? So antivirus posture check. All right, so pretty straightforward and simple. Let's simply ask if a software is found. So software, and we're looking for our antivirus. And I think I'm going to pick on CrowdStrike today. Love them as a vendor. They're awesome. We have lots of customers who use them. Their endpoint is called Falcon. So if we find Falcon endpoint sensor on a device, great. We're not going to have to do anything. That's the case that we want to see. If Falcon endpoint sensor is not found, though, we're going to mark this device as untrusted. Untrusted simply means that when you try to log into the device using a single sign-on tool like Okta, Duo, or Azure AD, it's going to tell you that you can't access the web resource that you're trying to get to because the device doesn't meet your trust process. Think zero trust compliance kind of stuff. If your antivirus product is found, though, we're going to mark this device as trusted because it does meet its baseline requirements. Once we've done that, we are then going to perform some remediation actions on this device. So I'm going to scroll down to my software list, and we're going to go find the Falcon endpoint sensor, and we're going to install Falcon endpoint sensor just to make sure it's available, should be running now, everything should be happy and safe. Once we've done that, we're then going to clone our original question statement of, is antivirus found? And if it is, we will then mark this device as trusted. closing that loop. All right, so that's the process in its entirety for our antivirus posture. Now I am going to save and close this workflow, and then we're going to turn this into a compliance policy. And to do that, we're going to publish this. We're going to run this on an interval, and I'm going to tell it to run every 10 seconds. So every 10 seconds, we're going to evaluate our devices, which I'm going to target this against my Salt Lake City, Utah lab environment. So any device in that location is going to automatically start checking in to see if the Falcon endpoint sensor is installed. And if it is, great. And if it's not, it's going to automatically start deploying it and evaluating the device for its trust status. Okay, so that's our first policy. Next, we're going to build a couple additional policies, one for your firewall status, and then another one for general patch and configuration compliance. And so for that, I'm going to start with our firewall policy. So in here, I'm going to look for firewall and ask the simple question, is your firewall enabled? By default, it has to be. So if it's not, we're going to mark the device as untrusted again, like we did before. And if it is enabled, great, no action required. Then once we've done that, we are going to enable that firewall. So enable firewall, great. Once we've enabled that firewall, we're then going to check again to see if the firewall is enabled. And if it is, we'll mark the device as trusted. So almost through with this posture check. This is going to allow us to enforce your firewall policy. So we're just going to call this firewall status policy and save. All right, so now we have an antivirus posture check and a firewall status policy. Let's just enable this so that this can run on my devices on an interval. And what's so cool about this, guys, is you don't actually need to have network access for these. These are running locally on the endpoints. So even if the devices are offline, there's no internet connection whatsoever, they're still going to have these policies running on them in the background, enforcing that compliance. If the software isn't found, it may have to, if the software hasn't been cached on the device, call out to Syxsense at some point in the future to get that content downloaded. But by default, if that content's available, it's going to install it for you. All right, so now we have our firewall status check. It's running, that's great. If any devices check in have issues, they're going to immediately start pushing out that work. And now we have just one more primary policy that we need to build, and it's going to be looking at our devices from a configuration compliance perspective. Now, this is where it gets a little bit more nuanced. Our tool is one of those, quote unquote, with great power comes great responsibility products. There's lots of contexts where what I'm going to show you is actually not a safe or appropriate maneuver. I'm thinking about, I don't know, domain controllers or web servers, anything that has a test dev prod approach towards management, you probably aren't going to want to use what I'm going to show you. But if you've got a laptop or a desktop or an endpoint that isn't as sensitive, it'd be perfectly safe to run a workflow like what I'm going to show you. What we're going to build is simply an evaluation on configuration and patch compliance. So we're going to go down a little bit in my list, and we're looking at the health of the device. And we want to know whether or not this device meets an attestation check. Has it been scanned recently for patches? If it has been, did it find any critical patches? And if it hasn't been scanned recently, we'll mark it as critical. So here we're doing a query against the device. We're going to look at our patch list, and we're going to check for the patch severity. So are there any patches that are either high or critical priority that are existing on this set of devices. If we don't find any high or critical patches, great. That's a good thing. We don't want critical or high priority patches hanging out on our laptops and desktops. If we do find some high or critical compliance issues, we're going to mark this device as untrusted. And this is also one of those areas we're going to probably need to dial down or dial up the enforcement posture, because it might be frustrating to your user if every time Google Chrome releases a new update, they suddenly can't access the internet because they're out of date. That's going to happen like once every couple of weeks. So you might consider adding additional posture checks, like not only do we evaluate whether you have patches pending, but are those patches older than X number of days? Which is definitely something that you could build using that query set. Okay, so we've established that there is an issue. So the device has been marked as untrusted because we found some high priority or critical priority issues. That being the case, we're then going to mark this device for a patch scan and deploy. So we're going to look at any configuration or patching items that need to be dealt with immediately, specifically critical items, and we're going to fix them on this device dynamically. And then, as with all of our other posture checks, we're going to tell this to run another device health scan against the endpoint just to validate that it's healthy and safe. So I'll drag over this guy here. We're going to tell it to look again for that same requirement. So patch severity greater than or equal to high, and hit save. And then if the device no longer finds compliance issues, which is the goal, we are then going to mark this device as trusted again, completing that loop. Okay, so here we're going to call this patch and configuration compliance policy. All right, and then we are going to turn this into another policy. Now, a change. The other policies are incredibly lightweight. And so I'm only running those on a 30-second interval because we can afford to do that. We're not taking up significant CPU cycles. But for this example, where we're now talking about patching an endpoint, potentially running a security scan on that device, we want to increase that cadence, or I should say decrease the cadence down to maybe once every 2 hours, because we don't want to overburden this device. All right, so interval once every 2 hours. Again, I'm going to target my devices in my lab in Salt Lake City, Utah. All right, and just like that, we now have a policy in place that's going to enforce a device health check against those endpoints. And if anything comes up, it'll immediately alert us to the fact that the device is not trusted, and it will then start deploying a patch scan and health check and fix any of the issues that it discovers, at which point it will revalidate that the device is healthy again and mark it as trusted. And what's so cool about this is on our map here on the homepage, as devices go in and out of compliance, you'll see these pins change from green to red as issues are discovered. And if you click into one of those locations, it will also show you a health check here. So these devices in particular, they're missing some content, and so they're showing up red. So you can get a lot of really good visual feedback into your environment. And because we have some of these checks running every 10 seconds or every 2 hours, it can really allow you to find those issues quickly and remediate them quickly. Because the end goal here is that you'd be able to create a compliance policy that is essentially continuous. So instead of running a weekly or monthly validation process where you might have critical vulnerabilities just hanging out in your environment for long periods of time, now you have a structured process in place that's going to manage it for you. It's going to manage it really quickly so that you can get back to the stuff that really matters, maintaining your compliance policy over the long haul rather than enforcing the compliance policy on a case-by-case basis. Okay, so that's part of the conversation around our zero trust and our intelligent endpointing process. But there's more to the story. We've shown you how you can enforce policies by doing a ZTNA style, like single sign-on product. What if you want to enforce policies locally on the device? What if you're not interested in spending a huge amount of money on a full suite zero trust product and you just need to enforce things efficiently? You can build out full scope zero trust within Syxsense by itself, no need for other tools. The way that you would accomplish this is by building out those posture checks. It's pretty much the same thing we showed you earlier. I've got something for antivirus, firewall, patching, all that stuff. And then we have not trusted actions. So if the device is marked as untrusted, rather than having to integrate into your single sign-on tool, you can manage it directly from Syxsense. So here, if the device is untrusted, we're simply evaluating Edge or Chrome or Firefox and turning them off if we find them. And then once the device is trusted, we're then going to re-enable that functionality. And then to take it a step further, we can even evaluate products and services. Like if a device is untrusted, maybe we block access to Outlook, or we automatically log out the user if we find something really severely wrong. For example, if you had a user intentionally install prohibited software, like a peer-to-peer file transfer service, we could immediately be alerted to that through our posture checking. We could then send them a message on their screen saying, hey, you have installed prohibited software. Please reach out to HR or security for further steps. And then 2 minutes later, we'll lock down their computer and remove their access. So it's a lot more than just patching. A lot of people come to Syxsense for patching, but our tool set is IT automation and compliance, which patching is just a wedge of that pie. So that's most of what I wanted to show you today. There's obviously so much more, but I don't want to bore you with the same repetitive posture checks. Some of the key takeaways that I want to give you, though, is that our posture checks are intended to be simple. I would not recommend building one large posture check with 20 or 30 unique actions. I would have 20 posture checks, each of which has no more than maybe 4 or 5 actions, because the intention is to keep this incredibly lightweight on your system and only truly have any sort of major interaction when an event is discovered that needs to be dealt with. Otherwise, we should just be pinging it periodically with some very basic telemetry until that event, like a critical vulnerability or a user-initiated noncompliance, occurs, so that we can remediate it without a significant bottleneck to the user experience. All right, so that is my presentation for today. If y'all have any questions about Syxsense, how we might be able to help your team simplify and also strengthen your IT management practice, please do reach out to us, and we'd love to have a longer form conversation.
Awesome. Thank you so much, Graham. Everyone have a great rest of your day.